Hey everybody, this is the Queen of Missiles. I'm back to show more progress on the visualization tool that I showed in the last video. So where we left off, I had some pretty much basic generation going. We were pretty much looking at purely TNT. Since then, I have implemented the nuclear thermobaric, antimatter, and even played around with some pathfinders to kind of get some more look into different things. As you can tell, I still got some CSS work to do, although visually the application is starting to do a lot better than it was, I believe, in the last video. Beyond that, we also have some additional features other than just being able to do the pathing and kind of show like what TNT is doing. I've also fixed the generation feature so we can actually generate some tile maps, kind of look at that. But what you might notice that is popped up in here is we now have the timeline here. So one of the plans, and I still need to work on this more, but it was to implement a kind of like timeline scrubbing process. So for those familiar with like doing any kind of video editing or doing any kind of like, uh, I think video editing is the only software that has this, but there's like video editing animations, like anything that kind of has the ideal that there can be increments of time in which something happens that you need to look at, edit, change, manipulate, so and so. Well, for looking at Blast, one of the things I wanted to do is do something similar because, seeing the results is cool. Like being able to kind of come up here and go like, I want to mess with TNT and click run is very awesome. I can see exactly how this is going to behave. I can mess with, my overlays and so on. That's really nice. Gets me a really good impression, especially when I zoom in and kind of stare at the data. Really, really cool. But it doesn't kind of tell me what this is doing as it runs inside of a game world. So for that, I have the timeline scrubbing, which I can come in here and decide, okay, well, I want to look at my initial, like how did we start? In this case, there's not a lot going on. So our initial is pretty bland. But then I go like, okay, well, I want to look at ray trace 1, then ray trace 2, and then so on. So I can step through these and pretty much look at how my ray traces are behaving in pretty much real time, which can be really, really, really useful for diagnosing what could be going wrong with an algorithm. Not just in terms of just kind of seeing like a pretty like time like feature. So I can sit here, I can kind of step through this, I can step through individual indexes, every single edit or every single action that a blast does in the software or any kind of algorithm that is running here will leave some kind of like edit metadata. And with that, I can sit here and individually manually step through this. But what I can also do, and I just finished this feature literally seconds before recording, so I'm hoping it doesn't break on me, is I can do automatic playback. And this is something I've badly wanted, and I have in the past messed with this, and I'm trying to remember exactly where I implemented it and how I had implemented it. But I did actually have something that would let me do kind of like play forward and backwards. I think I did that with a different kind of algorithm than blast-based logic because I wanted to see how pathfinders behaved or something along those lines. I have a tool out there somewhere. I'll find it one of these days and I'll show another video of kind of like how that is behaving and working. But from where we currently are, I can click start and I can sit here and watch how this works. Now the heat map still needs more work because it's going to run off of pretty much min maxes. So it's going to rapidly sit here and change through colors, which kind of isn't really great because you can see how it kind of turns brown in the middle. But for the purpose of what we're kind of doing, I can sit here and watch this and actually see that this is behaving. And for reference, this is vanilla TNT. So this is not, something custom I wrote. We're kind of watching exactly how this would behave inside of the game. So in terms of that, you can kind of see it's kind of like going either side, which is really interesting to learn that is how the algorithm does behave. Now, the algorithm in the game version would be running on 3 axes, not 2. So the order by which those rays happen might be slightly different. This is something where when I get the 2D version of this done, I really want to jump into a 3-dimensional version if I can even remotely figure out how to do that in JavaScript. And get those renders so we can actually watch how this behave in a 3-dimensional setting and maybe do some like spin maps where we can rotate around it, kind of look at like how it's functioning in that 3-dimensional setting and how it's behaving. But at least in this setting, it's working really, really well. Like I can mess with that to my heart's content. I can also stop it at any given time, and if I go like, oh, I wasn't really paying attention, let me go back to this previous setting. I also can change the speed on it. So if I want to go faster, I can click and have that just run through blazingly quicker. Lowest you can get that down is to 1 millisecond, which surprisingly this renders really fast, because how this is running in the background is I'm rebuilding the entire map over and over again every time it indexes forward. I'm hoping as I go later on that I'm going to improve this render, make it run faster, make it less error prone. But for the most part, I can sit here and do this. Now, for larger blasts, I haven't actually got around to testing those. So we're going to go grab, let's grab the Pathfinder. Because the whole reason I wanted to work on this today is I was working on the Pathfinder yesterday, right before my fiance forced me to try to go to sleep, which did not work because I am awake. It is like 7 a.m. I have not slept. So you can see that just completely, utterly failed. But she was trying to get me to like go to sleep, and I was breaking this Pathfinder over and over again, and was kind of wondering like why it wasn't working. So we're going to quickly run this. And I think I have it somewhat fixed because I was working it earlier. But the purpose of like Pathfinders like this, and it's not really truly a Pathfinder. Because the ideal behind a Pathfinder is you'd be going from point A to point B and trying to find some optimal route between those two, or some kind of thing that works. Like either first path, you would find first best path. There's a ton of different algorithms. This is kind of like an expander. It just kind of expands out and collects as many tiles as it can, which for the purpose of working on ICBM is really, really useful, because we can actually use this algorithm to figure out all the different blocks that are exposed to an area and then just kind of path them. In the past, when we were working on ICBM 2, which was the non-classic version back in 1.7, several of the algorithms did use this because this is much more performant in terms of like runtime than ray tracing, but does have some downside where it will wrap around corners in really funky ways. It will ignore certain barriers. There's things that needed adjusted. But in terms of testing, though, because getting back to that ideal, I can actually stare at this, and this one's got some interesting features that we're going to be using potentially, hopefully, in some of the other blasts. I can actually detect what type of end cap each of these paths are. So I can tell, is this a collision? Have I pathed this spot already, which is the red lines? Grays are my normals. Blues are my end caps. So they're basically saying like, hey, this is the end that path has reached. It cannot go any more forward. There's no more progression for that to do. I'm also kind of scaling it by index into distance wise. And I can kind of get a pretty reasonable idea of what's going on here. But in terms of kind of what it's doing, and I just realized it is not indexing itself very well. So we have kind of everything falls under pathing, so there's no real phase, and there's just the end version. So this is not really set up very well to do this. For reference, what these actually are down here, these are called bookmarks. So when you run the TNT, I have the TNT set up to bookmark every ray trace, so that way we can go back and look at individual ray traces. But with a Pathfinder, it's a little harder to do that because you're not having any guarantee of like what's part of the same path. Now, if we did recursion, I can bookmark trees or splits or so on, and possibly try to group them together in a way that sort of makes sense. And then the bigger marks down here are marking sources. So we have a source, which is a map initialization source, which is basically this panel over here. Everything in there falls under a init. And then we have the pathing itself. So I'm going to go init, and I'm going to actually zoom out a little bit. And then we're going to click start. And I'm going to watch how this behaves. This is supposed to be a depth first Pathfinder, and based on this, it looks like it's behaving closer to a breadth first, for those who are familiar with it. But at least tells me how this algorithm is behaving, as I can kind of watch not only the heat map change, but I can watch a lot of these tiles kind of fill in over time. And then if I want to, I can actually slow this down, which will actually be really useful in the case of what I'm doing, which is debugging. And I can't really change the size. Changing size will reset the whole playback. I can hit start on here, and I can watch how it's behaving. So it goes up, down, left, right, and we can kind of sit here and watch how this functions. And there's an interesting thing. This is kind of where the debug is really useful. So let me click stop there, and let me go back. So we watched it go forward or go up. And then if you notice, it went backwards. This algorithm is not supposed to do that. So this is where playback is incredibly useful for working on our mods, not just ICBM, but atomic science and any other project we work on, is I can sit here and I can watch what it does. So one of the next things after I kind of finish up doing EMP, because this whole entire tool is being developed right now, so I can work on EMP logic and blast pressure waves. The next one we're going to work on is the heat maps for atomic science reactors. So atomic science reactors actually have a current bug where they won't go further than a few blocks. So we can dump those algorithms into this tool, and we can actually watch how they behave, and they behave based off of pathfinders, so they behave off this similar algorithm. And what could be happening is we could be seeing not necessarily this exact bug, but we could be seeing similar styles of bugs where when it's trying to path, it's consuming too much energy, and therefore the reactor can't spread the heat out far enough to heat up the water in multiple different areas. But this is pretty cool. I'm actually really happy with this because I can actually watch how my algorithms are behaving in real time. I don't know why the heat map decides it wants to kick on right at this moment. I have a feeling what's actually happening. This is kind of hard to really visualize here, but I think if I turn off my tiles, no, yeah, these are all the same. So what ends up happening is because every tile has the same exact value, the heat map just decides it doesn't want to render, which is unfortunate. I'm going to have to go tweak it a little bit, but I know why I ended up doing that, because when we implement the antimatter, the antimatter has some really quirky behavior. Turn this on, click run. One, antimatter is a very strange thing. Two, I have no idea why this didn't actually break any blocks. When you talk about like trying to test things real time, oh yeah, it did. Okay. Antimatter is huge, just for starters. For those who don't really get an understanding of the scale of this thing is like massive. And it pretty much just generates a hole in the ground. There's like no better way to put this. But for those who've like never dug into the code for ICBM or really like thought of like how our code actually works, antimatter, because of the way it behaves, pretty much ignores all logic and rules and just goes, I'm going to delete blocks. It doesn't really ray trace. It doesn't do anything special. These lines you're seeing here is basically a for each loop going through of like what blocks here, what blocks here, what's blocks here, and so on. Now it's doing it in a very unoptimal way because it's going through blocks it's not planning on actually editing. Because what we do is we go through, we map and go, I'm going to start at 0, 0 over here. And I'm going to go, is that within the distance check? And it goes, no. Okay, so I'm going to ignore it. And it's going to go through and it's going to keep doing that until it finds something that it actually plans to collect. It's going to collect it. It's going to decide, am I part of the feathering range? Because it's going to delete some blocks or add some blocks based on feathering to give it a kind of nice fuzzy edge. And then it's going to do other basic checks like, can I actually destroy this? Because antimatter, it sorts sand and water blocks to the front of it, so that way those get removed first, so you don't end up with like weird behavior of like falling water in the middle of the screen. But with this, we actually could do a playback on this one too. Let me scale all the way back out. So we're gonna go back to init, and this is where the system is probably going to struggle. Yes, those buttons just don't even want to work. Yep, that is like, I'm pretty confident froze. So antimatter is a bit of a struggle to run in here, and it isn't actually the code in the background running. Like, I'm pretty sure all the data is already computed, it's already run, it's already knows what it's supposed to be doing. I think the part that's failed is we're using a JavaScript canvas, and it does have some performance issues in terms of trying to render stuff with it. Canvases work really well for basic stuff. This is not basic. This is kind of past basic a while ago, and I'm also not using it in the most optimal way possible. There's a lot of like performance improvements. Like at this scale here, I probably shouldn't even be drawing the arrows because they won't matter. Actually, if I turn the lines off, nope. Okay, so I want to see if this will actually let me refresh this page, or if this is actually a completely dead page. I'm going to assume it's a dead page, and we're going to kill it. This is why web development is like sometimes a hassle, is that if this was a Java app, I could just kill the Java app and do it. But with it being inside Chrome, I'm at the mercy of Chrome if it wants to close stuff or not. So what I'm going to do is I'm going to do that. We're going to go back into the antimatter so I can kind of show how this works. And I'm going to, actually, I'm not going to draw the size, because I think if I turn off heat map, I turn off the grid, and I set the scale before I start. Click generate. Actually, let me add some modifiers too, just to show you all that this stuff actually does work over here. Do some planks, I guess. We'll do 0.2 generate. Oh, I need to actually set the size big enough. And I'm planning on putting more generation tools over here rather than just like randomizations. Just kind of get started. Oh, that looks absolutely terrible. Let's throw I don't know if sand looks any better. it marginally looks better. I'm gonna do some lava. That's what I've been doing last time I was messing with this, is because lava looks a little bit nicer. Okay, let's zoom out a little bit. Uh, that's too much zoom. Oh, it's not gonna let me. 8 might be a good. That way it gets it completely in picture. Well, almost completely in picture. I think 7 is gonna be where we have to be at, and that just doesn't feel good for you all to watch because that's like only half of the screen over here. I'll have to work on a way I can downscreen parts of this so we can get a little bit nicer visual. If I actually had some editing tools and actually wanted to do editing on this video, I would do this in post-production and just expand it to be the full screen. But that takes some wizard magic that I don't tend to do. Okay, so we have, you can see like the playback here, so there's that modifier running, so I can actually go back and hit initialize and go back and click that. So the playback works on that. We have our antimatter configuration ready, and I can click run. See, the hole has been created. Now I should be able to go back to box 0. I'm going to set this to 1 millisecond per re-render. And I'm going to pray this is not going to completely stall the machine out. Maybe 1 is too small. There we go. It might take us a second or two to get through. Actually, you know what? Let me jump to after pathing, because the pathing itself takes time. So here's us removing blocks, and this is where things get interesting. So now I've learned a little bit about how some of this algorithm works here. So we're removing blocks from the center, but this should be sorted. So we should be going from the very center of our antimatter blast and going forward, not doing this really slow kind of like picking out tiles bit by bit. So there either is something wrong with the JavaScript implementation of this, or the Java version that we duplicated it from may actually have some flaws in it, which could be causing it to do some weird things, which is why testing tools like this are incredibly useful. And then let me zoom in a little bit more here so we can watch that center. Now let's see if I can make it faster. Let me stop and start again. Because in the background this controls a timer, is what this actually controls. There we go, that's faster. It's still really slow. So I think what I need to also do is add another control of not just playback speed, but playback intervals. So instead of incrementing by 1 at a time, I could tell it to increment 10, 20, 30 or so at a time. That's still pretty slow though. But the fact that it's supposed to be incrementing at like every 2 milliseconds, I don't feel like it is. So we're going to click stop a few times to make sure that stopped. We're going to click start. That feels like that's actually going once a second. And that could be the time it just takes for it to re-render the entire frame, is what we could be running into. Is that even though I have it set for playback speed at that, it could be taking that entire time to re-render the entire system. Which would be really unfortunate, but it actually does make sense. So just to test that theory, I'm going to drop the size on this down to 10. I'm going to reset. I'm going to click run. I'm going to go back to pathing. I'm going to click start. Yeah, so that's significantly faster. So yeah, we were definitely running into a scenario where like the render time, there is delay. But it is playing back, so it's working. So this feature does actually run. And this is as fun as it to look to get drawing basically a hole in the middle of the map. Let's try to go grab one of the other explosives. So the other types that were added were the sonic, thermobaric, and nuclear. These all run pretty much the same exact algorithm. They just have different settings. So the reason for putting like multiple entries in here is these are basically configurations. And if you kind of go here, it'll even tell you nuclear configuration for a blast large algorithm. I am thinking about grouping these in this menu down the road of actually telling you what algorithm they're running. So when we go to add more of the vanilla types, and when we have like the wither or ghast and stuff like that, I will probably group these under vanilla or like Minecraft explosion. That way we know what algorithm they're running, and you all can actually see the same thing. So let me go grab this. I'm going to click reset. And I'm trying to decide if I want to let this run at full size. I think I am going to let this run at full size. I, however, am going to reset and tell it to go more centered. We're going to tell it to go 30, 30, and I need to actually update this to be somewhere in the middle of the block. I am going to probably change these to no longer actually allow decimals, just because like most of the time we're testing this, we're going to be testing at tile positions. So let me click run on this. I do not actually see the results. Ah, there's our results. Okay, so this did not break blocks. And I'm not particularly sure why it didn't break blocks. And I think that just might be my bad on editing the data, because I did not test this very massively, but we can at least let this do playback. So we're going to go back to the start of this. We're going to click start. And you can see just how this behaves. This just ray traces straight out. So very similar to how the nuke behaves. Only we're dealing with an algorithm that is going to jump a little bit different. So if I can get down in here, it's a little hard to see. Oh, this is where I need to actually integrate some better logic of how to do scrolling. Because what I should be able to do is I should be able to click in the middle here and with my middle mouse button, zoom in and out. But we can't actually watch that run. So we're actually watching it ray trace out. It's actually really, really beautiful. I might have to do some time lapses with OBS here later of just these running and then speed them up in post, just so that we can see these algorithms run and behave and it just do what they're supposed to do. It's really, really cool. And let me turn off the tiles in the background. And yeah, so we can actually see what these are doing. I can turn off the heat, just kind of watch the rays behave. And you can see as it gets smaller and smaller how it loses energy as it passes through various blocks. That's really cool. And I could jump ahead. And I believe these rays are not sorted properly because I'm just sitting here looking at them. Yeah, they don't seem to be sorted where I would expect them to be sorted. Definitely something to be working on later, but I'll leave you all here and I'll be back with some more videos as I make more progress on this or ICBM or anything.